Triangle ABC is shown below. What is the tangent of A? Whenever we see these words, tangent, what do we need to write on our paper? SOHCAHTOA. Okay. Also, if you don't remember SOHCAHTOA, the ratios are written for you on your green sheet. So you would just literally go to tangent and read what the ratio is. Okay? That's also an option. So you would go to the angle they gave you, which is angle A, and label your sides based off that angle. If we go across, that's our what? Go to our 90, go across, that's our, and the side left over. So based off SOHCAHTOA, what does the ratio of tangent look like? Here's tangent. What's our ratio? Yeah, opposite, which is 24 over hypotenuse, or adjacent, which is 10. Are we allowed to leave it like that? Can we not simplify? Try to the decimal. You can simplify it. If we simplify it, what do we get? 12 over 5. Either inch is acceptable. On your Canvas quizzes, because in the past I made you simplify. So then we learned you didn't have to simplify. So I haven't changed those answers yet. So if you do your Canvas practice and you're like, oh, I wrote it right, I just didn't simplify it, raise your hand. I'll check just to be sure, and I'll give you those points back. It's easier for me to just change your score than go back and choose a bunch of answers. So keep that in mind. If you put the unsimplified, so you typed in 24 over 10 in the Canvas, but it said you were wrong because it's 12 over 5. Yeah, you're technically right. So just show me that, and I'll give you your points. Okay. Questions over that one? A big common thing that happens is we see this, and we solve for the measure of angle A. This just, whenever you see the sine or cosine or tangent of an angle, we just want to know what is the ratio. When it said what is the measure of angle A, then you do all this work to find the actual measure. Okay? This just wants to know the ratio. So if we take a look at 2, we want to find side AB, which is that side right there marked with X. If it wasn't marked with X, I would mark it. Okay? What are we going to use to find that missing side? Are we going to use trig or the Pythagorean theorem? Notice I have a right triangle. Trig. Why can't we use Pythagorean theorem? Yeah, they only gave you one side, so you have to know at least 2 sides to Pythagorean theorem. We only know one, so we have to use trig. So start with the angle they gave you and label your sides. Across is opposite. Go to your 90, go across, that's our hypotenuse. And the side left over is the adjacent. If you look at SOHCAHTOA or look at your green sheet, okay, which ratio do we have to use to help us solve? So you sine, cosine, or tangent? Cosine, yeah. Our adjacent had our number, our hypotenuse had our variable, so we're going to use cosine. So we're going to say cosine of our angle is equal to the adjacent over the hypotenuse. Is x up high or down low? Down low, so what are we going to do? Switch her out. So these two switch places. So that becomes x is equal to 11 over the cosine of 37. If x was up high, what would we have done? Multiply. So then you plug it in your calculator exactly how it's written. Here's the thing. If you have a graphing calculator, non-graphing calculators don't really need to worry about it. Graphing calculators, though, you do. So I make sure I'm paying attention. Okay? I see your graphing calculator out. I don't even need your graphing calculator. Because we have to restart your calculator, okay, when you take the OST. And when that happens, it automatically puts your graphing calculator in the radians. But what does our calculator need to be in? It needs to be in what? Degrees. To do that in your graphing calculator, you're going to hit mode. You're going to arrow down to where it says radian, arrow over to where it says degrees, and then hit enter. So the second you restart your calculator, do that. Get it back to you, do that. Right? If you forget to do that or you don't remember how to do that, so I don't think we can't tell you. You can use Desmos. Right? The state calculator for Desmos, is automatically in degrees. So you don't even need to worry about how to remember to change your calculator. Just use Desmos when you have a trig problem and you're plugging sine, cosine, and tangent into it. To get those trig functions, what you're going to do to plug this in, if you're plugging it into Desmos, you're going to say 11 divided by cosine over 37. So down here, we do 11 divided by, to get cosine, you're going to go to functions. And there's all the things you need. So you're going to go to cosine 37, and it gives you the answer. So if you don't remember how to change your calculator mode, or you don't even want to worry about having to remember how to change your calculator mode, just use Desmos. Okay? So if we round to the nearest tenth, it would be 13 point what? 8. X is equal to 13.8. That is the length of that side. Okay? Because the 7 would bump that 7 up too. Okay? Questions over that? When you get all those trig functions, you literally just go to functions. And they're all in. Okay? Questions over that? If we take, we're going to skip this one because we'll see an inverse one in that bottom one. So skip it for time. I know it's different on mine, but just skip the next one. You'll see something like that on the last example. For number 4, it says angle A is a complement of angle B. Which equation about the two angles must be true? What does complement mean in terms of angles? What do complementary angles mean? Add to what? What did they add to? 90. We'll get to the actual answer here in a second. They add to 90. So whenever we have complementary angles, what do we know about the sine of one and the cosine of the other? They're what? The same. So then, Trent, what's our answer going to be? D. Okay. Whenever we have complementary angles, we know the cosine of one is equal to the sine of the other. They ask this question in different ways. Okay, so a way to answer this question is when you have a multiple choice question and their sine is equal to cosine. To determine what the right answer is, you're going to pick the answer that has both things, sine and cosine. Okay, and you're going to pick the answer that also has the two angles. So the two angles in this instance are A and B. So that's what you want to look for, sine and cosine in both angles. So like A has both angles, but it doesn't have cosine. These have both sine and cosine, but it doesn't have both angles. And this doesn't have both angles. Okay? So look for the one that has everything. Sine, cosine, and both angles. Okay? Questions over there. Also, make up numbers. Okay? Make up angle numbers. Make up, okay, I'm going to say sine is 30, or A is 30 degrees, and B is 60 degrees. Pick two angles that add to 90 degrees. Plug it in your calculator and see which one makes a true statement. Okay? Just make up numbers. Questions over. 2 is dealing with a similar problem, but backwards. So if the sine is equal to the cosine, what do we know about the two angles? They equal 90. They don't equal each other. They equal 90. They equal 90. They don't equal each other. So we know that 74 plus x equals 90. So to get x by itself, what do we need to do? What do we need to get x by itself? Subtract. Just subtract 74. So we subtract 74. What's 90 minus 74? So the measure, or x, is 16 degrees. They're not the same. If you do the cosine of 74 in your calculator and the sine of 74 in your calculator, you will not get the same answer. It's cleaning. Yes. Okay. So last one. Last one says, two boats are traveling toward a lighthouse that is 200 feet above sea level at its top. When the two boats in the lighthouse were collinear, so what does collinear mean again? Collinear means linear means no. What does linear mean? What does linear mean? What does it sound like? Sounds like what? Line, right? Co means same. Same line. Collinear. Same line. The boats are exactly 200 feet apart, and the boat closest to the lighthouse has an angle of elevation to the top of the lighthouse of 15 degrees, as shown. What is the value of x? Round your answer to the nearest hundredth. So x is an angle inside a right triangle, because if we look at this here, this makes a right triangle. What do we use to find the missing angle of a right triangle? Trig. We have to use trig. We have to use SOHCAHTOA. Well, the problem is, I know this side here, but do we know the length of our bottom side? We know the length of our up and down side, but do we know the length of our bottom side, the entire length? No, we only know a piece of it, right? We only know what it is from here to here. Right? So then, we have to do something to find it. So I noticed that the missing part of the triangle that we need, so the bottom part is the base of this right triangle right there. Right? Well, what can we use to figure out the bottom of that orange triangle? This is what we're trying to find. What can we do to find it? Can we use Pythagorean theorem? No, we have to use what? How do you find the missing side of a right triangle when you can't use Pythagorean theorem? Right, we have to use SOHCAHTOA. So when we use SOHCAHTOA, label your sides. I'm going to start at my angle. I'm going to go across. That's my opposite. Go to my 90, go across. That's my hypotenuse. The side left over is the adjacent. So based off what we labeled, are we going to use sine, cosine, or tangent? We'll think which one has your number, which one has your variable. Tangent. So we're going to say tangent of our angle, which is 15, is equal to the opposite over the adjacent. Is x up high or down low? Down low. So we are going to do what? Switch a row. I know some of you tested and are a little tired, but I know some of you have not tested. Make sure we're paying attention and participating. And then plug that in your calculator again. An alternative to your calculator is just use Desmos. You're going to type in 200 divided by, hit the functions bucket button, tangent 15. So that's about 746. Everything else is a whole number, so I'm going to round to the nearest whole number. 746 is the length of that bottom part. If it's helpful, draw that big green triangle off to the side, because there's a lot of writing going on. It's a little bit messy. I know the up and down part is 200. I know I'm trying to find x, which is that angle right there. Is the length of that bottom part 746? No. What do we have to do to find the length of the entire bottom part? 250. What do we get when we do 746 plus 250? 996. So that's the length of that. Now that we know what the length of that bottom part is, use trig to find the missing angle. So start with the angle we're trying to find. Go across, that's your opposite. Go to your 90, go across, that's your hypotenuse. Side left over is your adjacent. Shortcut to this, when we have the double trig problems, whatever gives it on the first one, 99% of the time you're using it on the second one. Okay? So if we use tangent on the first one, more than likely, what are we using on the second one? Tangent. We're going to say tangent of our angle, which is x, that's what we're trying to find, is equal to 200 over 996. When the angle is missing, it's not a curse, what do we use? The inverse. So in your graphing calculator, you're going to hit second tangent, and then type in this fraction. So graphing calculators, you hit second tangent, and then type in the fraction. If you're using Desmos, go to functions, and just hit the tangent with a -1. And then type in that fraction, 200 divided by 996. Oh, just make sure you delete everything else out there. 200 divided by 996. So, the length of that, or the measure of that angle to the nearest hundredth would be what? 11 point. 3. The 4 would have bumped the 5 up or keep it the same? Keep it the same. So it's 11.35. 35 degrees. Questions over that?